Yeah, hello guys. Yeah, welcome back to my channel. This is chemistry call. As promised earlier that I'll be dropping videos for those preparing for 2022 JAMB. So now, the first topic I would love to start with is what we call the chemical bond. And before we start the video, I want to appreciate the efforts of our subscribers for the love they show in subscribing, and also for them to have shared with them colleagues and friends. So now, this morning topics is what we call the chemical bond. And what is bond and what is chemical? So if, for example, now I have two atoms coming together to form a particular compound or a particular chemical compound, that is what we call what? Bond. But to explain this particular chemical bond now, let's start with the definition of this now. So I can say chemical bond is the lasting attraction between ions, molecules, atoms to enables them to form a chemical compound. So looking at what you have now, I said there was the lasting attraction between ions, molecules, ions to enables them to form a chemical bond. That is, now if I have carbon, I have hydrogen now. So if these two elements are coming together, they are going to form what we call what? A chemical compound, which is what? CH. Are you getting it now? So now, one thing you should understand about this chemical bond as a JAMB is there's what we call the maximum number of an electron. That is your K, L, N, and what? Shell. Are you with me now? Your K, L, M, N shell will be a guide in what we call this chemical bond now. So now class, with this K, L, M, N shell now, it's telling you guys that your K will have one electron, your L will have two, your M will have three, your N will have what? 4. So and this K, L, M shell now, if you have a shell like this, the inner thing you have here is called the nucleus. Are you with me now? So now, this what we have here is called what? The shell. So you can either have it in K, L, M, we have what? N shell. So, the main thing you should understand now is, if you grab that, for every chemical bond, it involves the attraction between ions, molecules, and atoms to enable them to form what we call a chemical bond now. So what is chemical bonding now? This one is chemical bond now. What is chemical bonding? So I can set my chemical bonding. So this chemical bonding, it's very simple in the sense that an understanding of electronic configuration is a fundamental understanding of chemical bonding. I can see the difference between chemical bond and chemical bonding now. An understanding of electronic configuration is a fundamental understanding of chemical bonding. So now, if I have sodium, so the atomic number of sodium is 11. So we can say our sodium is 281. Chlorine, atomic number 17, I have 287. I have nitrogen 725. Oxygen, atomic number 8, we have 26. So all these elements you have here, all these one you have here, the electron outside here, are meant to be known as the outer electron. So now, this is what we'll be using more, because I said for every chemical bonding, you must have an understanding of electronic configuration. So with the knowledge of electronic configuration, which I have dropped the video earlier, will serve as a guide for you to understand what we call the chemical bonding now. So now, let's look at the types of chemical bond. The types. The first one we'll talk about is electrovalent or ionic bond. The second one, covalent bond. The third one, we have coordinates, covalent or dative bond. The fourth one, we have hydrogen bond. The fifth one, we have metallic bond. The sixth, we have van der Waals force. So now you can see we have these six types of chemical bonding now. So class, the one I'll treat most, because for your JAMB question and how to attempt the question in a brief time, because I told you guys in my last video about time maximization, how to manage your time when it comes to answering some question on the JAMB question. So with what you have here now, I'll treat the part of the ionic bond, covalent bond, dative bond, or we call it coordinate bond or coordinate covalency, because these three types is where we are going to find more of your question for JAMB now. So now let's start. What is ionic bond? So we have electrovalent or ionic bond. So the definition of this now in a short form, it involves the transferring of electron from a metal to non-metal. This is now, it involves the transferring of electron from a metal to a non-metal. So what we call the donor acceptor principle. So this donor acceptor principle, it means that for every donor they are what? Metal. For every acceptor they are non-metal. So how does this involve the transferring of electron between a metal and a what? A non-metal. As you can see from the name, ionic bond, or we call it electrovalent bond now. So let's see like 3 or 2 examples that will show us how they transfer the electron from a metal to a non-metal. So now I have sodium chloride, I have calcium chloride, and I also have magnesium chloride. So I will play with these 3 examples of electrovalent or ionic bond now. So don't forget earlier that I told you guys that if you are to understand your chemical bonding, you must have knowledge of what we call electronic configuration. I have a full picture of that particular word, electronic configuration. You can check that on my previous video. So now, sodium atomic number is 11. Chlorine atomic number is what? 17. So now, let's go that our sodium is what? 281. Chlorine 287. So the first inner shell we are going to do, we have 1, 2. The second one is 8. 1, 2. While the last one is what? 1. So let's check for our chlorine now. 1, 2. So as you can see now, so the question now is, how did they transfer electron from a metal to a non-metal? So we are going to ask ourselves this: which element between sodium and chlorine will attain its octet state first. That's the question now. So this sodium here now, we transfer one electron to chlorine. Why? Because chlorine need one electron to attain its octet state, while sodium need what? 7 electrons to attain its octet state. So we'll be using, it means that sodium will transfer one electron from its outer electron there, or the outer shell, to attain what we call what? A electrovalent bond now. So are you getting it out? So this is how we call what? The metal or the non-metal. So this is what? The metal, and here we have what? The non-metal. Are you with me now? So it shows you guys that the definition of electrovalent or ionic bond, that it involves the transfer of electron from a metal to a non-metal. And I told you guys that the principle that will guide it is called what? The donor-acceptor principle. So that is why your electrovalent bond did not form what we call a molecules. Rather, they form what we call an aggregated ion of either a positive or a negative ion. So that the one that donates one electron now, we have what we call the positive sign, while chlorine accepts only one electron, so we have what? A negative sign. So you can see that they did not form molecule, rather they form a aggregated possible ion. Now, these are our donor, these are what? Acceptor. So now, let's take a look at another example of calcium chloride. So we have calcium, atomic number 20. We have 2 of what? The chlorine. So one of the chlorine will be here. The second one will be what? Here. So with this now, I can see that I have 2882, 287, 287. So when you add up this everything here, you're going to have 20. This you have 17. So now, class, to make it short, I've shown you guys the shell for these are our K, N, M. So now let's only use the outer electron to show the ionic or the electrovalent bond now. So the outer electron of calcium is 2. For chlorine we have 7. We also have what here? 7. So this now, the outer electron 1, 2. Don't forget we are using only the outer electron now. So this we have 7, 1, 2, 3, 4, 5, 6, 7. The second one, outer electron 1, 2, 3, 4, 5, 6, 7. So now class, let's see now if truly, or let's say the one that will attain its octet state first. Calcium what? Need just 6 electrons to attain its octet state. Why these two chlorine need one electron to attain its octet state? The thing is now, it tells us that the calcium will be the one that will be donating, because one of these will be transferred to this, while the second one will also be what? Transferred to this. So now, you can show it with this arrow. Moving here, we have this. While this, we have this here. You can see it now, that when the calcium donates its outer electron, the left is what? 288. When chlorine accepts the electron from calcium, we also have what? 288, 288. You can see that they both have what? 8 outer electron each after undergoing what we call the ionic or electrovalent bond now. So now class, as I've told you guys earlier that for every ionic or covalent bond, electrovalent bond, they did not form what we call a molecule. Rather, they form an aggregated charge of either a positive or what? A negative ion. So I think that would be one of the properties of ionic bond. So for calcium to have donated 2 electrons, we have 2 plus. For chlorine to have donated to accept one electron, we have a negative here, we have a negative sign here. So that's a clear picture of the electrovalent bond. So now the last one is magnesium chloride. We have magnesium chloride. So magnesium atomic number is 12. Chlorine we have 17. So I have what? 17. We are using the same method. So for this we have 282, 287, 287. So the outer electron of magnesium is what? 2. This we have 7. So now, because we have a good knowledge now of this ionic or electrovalent bond now, this will transfer to this. This also will transfer to what? This. So tell you guys that for every electrovalent or ionic bond is what we call it involves only the transferring of electron from a metal to a non-metal. So now let's move to the next one, which is covalent bond. Covalent bond. Covalent. No, before we move to the covalent bond now, let's look at the characteristics, or we call it uniqueness. Characteristics of electrovalent or ionic bond. The first one, are you with me now? They are solid. They are solid at room temperature and less volatile. So they do not form molecules, rather they possesses aggregated charge of positive and negative ion. So the third one, they have high melting and boiling points. They are good conductor of electricity now. So these are the characteristics of electrovalent or ionic bond now. So the first one is they are solid at room temperature and less volatile. So they do not form molecules, as I've said earlier. Rather, they form or they possess aggregated charge of either a positive and a negative ion, which is what we have here. Positive and what? Negative ion. They have high melting and what? Boiling point. And also, they are good conductor of electricity because of the charge they have there, a negative and a positive. So telling you guys that we have what? An anode and what? A cathode. Electron leaves and also electron what? Enters. So the next one is what we call covalent bond. Mind you, I'm only explaining the three: the covalent bond, ionic bond, and dative covalent bond. We call it coordinate covalency. So these involve the sharing of electron between the same atom or different atom. Between the same atom or different atom. Example now. We have water, we have methane, we have ethene, we have oxygen gas, we have this carbon dioxide. So let's play with these four examples now. So now I said for every covalent bond this involves the sharing of electron between the same atom or different atom. So let's see how they share electron between the same atom or different atom now. So the first one is we have water. So let's see how many of the hydrogen atom they have here. We have two. Telling you guys what hydrogen and oxygen are what different atom. Oxygen gas, the same atom. So I have a clear picture of how what we mean by covalent bond. So the hydrogen here is how many? Two. One hydrogen. A second what? Hydrogen. So our oxygen, I showed you guys earlier before, we have 2, 6. Atomic number what? 8. 1, 1. So the outer electron of oxygen is 6. We have 1, 2, 3, 4, 5, 6. So let's see how they share the electron now. So the first one is this, the hydrogen. You can see they are closed together. You can see it now. Another hydrogen now. So that is why your covalent bonds will always form in molecules and also have a definite shape, because the clear picture of this hydrogen, this water now, I can have it in like this. This is our oxygen. So you can see how they form the bond angle there. So I have oxygen here, and I have hydrogen here. I also have hydrogen here. So I have 104.5 or I have 105 degree. So it is called either a V shape or angular shape, because these two hydrogen here are the one that share the electron. So now this one here, I can say that they are called a bond pair. This they are what? Lone pair, lone pair. So telling you guys that for this water now, according to Sedu Power, it states that for every or for any atom that shared electron, either we have a bond pair, or bond pair, we have a bond pair, lone pair, or we have a lone pair. But here we have a bond pair, lone pair. So now the next one. The next one is 18. This one we have water, 18. So we have two. How many of the carbon do you have there? 2. And the outer electron of carbon is 6. I mean, so no, atomic number 6. So we have 2, 4. Another one, 2, 4. Why my hydrogen we have 2. One of the hydrogen. Oh, 18. This one should be, yeah, it's on. So another hydrogen. So now this will be the central atom now, because we have C2H2. So the outer electron is what we'll be dealing with here. So we have 1, 2, 3, 1. The second one, 1, 2, 3. So initially they have to what? Bond together, because they are sharing the same electron. So must be close together. 1, 2, 3. While the other one is 1, 2, 3. Can you see it now? The last one is here. Why the last one is what? Here. Mind you, we have 2 hydrogen left there that are not yet to be shared. So can I have one of the hydrogen here? Hydrogen. Second one here. So when you count it now, they must complete 8. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see from this part now, let's count. 1, 2, 3, 4, 5, 6, 7, 8. From this part here, 1, 2, 3, 4, 5, 6, 7, 8. You can see it now. That they both complete octets now. So when you bond this together now, where they share, so you can have this triple bond, the carbon atom, this electron here with hydrogen, this one here with what? hydrogen. So that what we call this what? We have a triple covalent bond. So that is why, in a nutshell, all organic compounds are covalent in nature. So the next one is oxygen gas. See, how many of the oxygen do we have? We have 2. So oxygen, atomic number 8. Another one, atomic number what? 8. So we have 2 C's. We have 2 C's. So this will show the first oxygen here. Outer electron we have 1, 2, 3, 4, 5, 6. Another one here we have 1, 2, 3, 4, 5, 6. So when they bond together we have what? A double covalent bond. Here we have a triple bond. Here we have a what? A double covalent bond. Here we have what we call the single bond here. So now I can have this to be the bond angle here is 180. Here we have 120. So let's take the last one, which is what? Carbon dioxide. So I would love to put it here. The D, I have carbon dioxide. So now carbon, it will be the central atom, while the oxygen will be bonded, will covalently bonded together with the carbon now. So I have the carbon here, outer electron, we have atomic number 6, so 4, 1 of the oxygen, 2, 6, another oxygen, 2, 6. So let's make use of only the outer electron. Don't forget that the carbon will be the central atom. This is my carbon. Outer electron is 4. So I have 1, 2, 3, 4. My oxygen, I have 1, 2, 3, 4. Can say 6. Another oxygen, I have 1, 2, 3, 4, 5, 6. So you can see now, they both shared what? The same electron. But the two elements there are different elements, which implies as well different atoms. So yeah, I can have it to be what? This. You can see it now. That's the truly they all belong to what you have on the board, and they all belong to what we call the sharing of electron. So let's look at the properties or the characteristics of covalent bond. Let's say the opposite of electrovalent bond, ionic bond, is the same thing of what? This, vice versa. So here they form molecules and have a definite shape, because all of what you have, they have their own what? Bond angle. So automatically they have a definite shape. So number 2, they are gases or liquid at room temperature. Number 3, they are weak conductor electricity. Number 4, they have no melting and boiling points. So now you can see now the properties of or the characteristics of electrovalent bond or vice versa will give us what? That of the covalent bond now. So now let's move to the next one, which is the dative bond. Then we'll move to the 10th question under this topic. So it is called dative covalent bond, while you can also call it coordinate covalency. So one thing about this dative covalent bond, or let's say you can have say equal distribution of electron are not observe. Because either we have what? A transfer or sharing of atom, which gives us a lone pair. Give us what? A lone pair. So example of this can say equal distribution of electron are not observed. We can have it as either a transfer, sharing of atom, which gives us what? A lone pair. So let's see how we can fully observe the lone pair now of a dative coordinate covalency. So I have water reacting with this. At the end, I have hydrogen ion here. At the end, will give us what? Hydrozonium ion. But one thing you should know about this covalent bond now, I can have transfer of electron there, I can have sharing of electron there, but listen, there must be what? A lone pair. You must be able to what? Identify your lone pair. So now let's play with this hydrozonium ion now. We have hydrogen ion here. So now, the first thing you have here is what? Water. The central atom is what? Oxygen. The way you guys show it under, or the way I show you guys under the covalent bond there for water. So oxygen is the central atom. Outer electron 6. Are you with me now? I have this. I have this. Hydrogen here is how many class? 2. I have this. I have this for my hydrogen. What you have here? Plus 1 hydrogen now, which is this. What you have here is called the lone pair. What you have here, that this one bonded to this called what? The bond pair. What really occur here is called the what? Covalent bond, the sharing this. So if we want to write this now, to show this what? Aggregated positive ion. We have the same thing here. Hydrogen, this. Hydrogen, this. So you will only be adding the hydrogen, but you will not show the what? The electron of that hydrogen, because it's impossible for it to have 3 electrons here now. So that's the reason why we have it as what? A positive ion here. You can see it now. The next one, when ammonia reacts with hydrogen to give us what we call what? Ammonium ion. So the central atom here is nitrogen. We have this 5. So my hydrogen is how many? 3. 1 hydrogen, a second hydrogen, a third hydrogen. So this one is called the lone pair, while these 3 are what? The bond pair. So it means that we have a bond pair, lone pair here, plus the hydrogen. So with this now, so we are going to repeat what we have here. The same method. So you have a closed bracket. What you have here, nitrogen. So now you'll be showing the hydrogen here, but you are not putting the electron there, because I told you guys earlier on that this hydrogen it is what? Impossible. So the positive ion will be outside. Do you see it now? So the properties of dative bond and covalent bond, they are similar. They are the same thing. Just that the only thing that differentiates between the covalent bond and dative covalent bond is that they have what? Less volatility. Are you with me now? So let's play with the 10th question. As I've promised you guys that for this 2022 JAMB, I'll be treating 20 topics, and each 10 questions each on the topics I'll be what? Treating. So that will give us what? 200 questions. So the first topic I started with is what? Chemical bond. And for the chemical bond, I explained to you guys that for every chemical bond, It is a lasting attraction between the ion atoms molecules to form what we call a chemical compound. And I explained I listed the 5 types of bond: the electrovalent bond, the covalent bond, the dative bond, ionic bond, metallic bond, and van der Waals force. So let's use the 3 major ones I told you guys that we always come out in your JAMB. And how do you attempt, or what is your approach to the question given to you? So now, the first one is, that's UTME 1978. So start number 1. Elements P, Q, R, S have 6, 11, 15, and 17 electrons respectively. Therefore, A, P will form an electrovalent bond with R. Q will form a covalent bond with S. C, R will form an electrovalent bond with S. D, Q will form an electrovalent bond with S. This question is JAMB 1978. That's the first question we tackle now. So now, with some knowledge of chemical bond now, they said elements P, Q, R, S have 6. So this is how you solve it. I know 3 guys, 40 seconds. So start counting now. My P is 6, my Q is 11, my R is 15, while my S is 17. So what kind of bond really exists here? My P is example of what? Elements carbon. Here we have sodium. This does know how to identify the elements, so you'll be able to what? Get your answer fast. This is now atomic number of carbon is 6, sodium 11, phosphorus 15. That's chlorine, have 17. So now let's play with the first one. P will form an electrovalent bond with R. My P is what? 6. My R is what? 5. So it is what? Wrong. Because the outer electron of carbon coming 281, 285, 287. Outer electron of carbon is 4. For phosphorus we have 5. So it's not possible that they involve the transferring of electron. This is now. They did not transfer electron to each other, which is what? Wrong. The next one. Q will form a covalent bond with S. What is your Q? Sodium. Outer electron 1. Your S, chlorine. We have outer electron 7. So the only thing that can evolve here is called what? Electrovalent, not covalent. So it is what? Wrong. A and B is wrong. C. R will form an electrovalent bond with S. So my R is what? The outer electron 1, 2, 3, 4, 5. S, outer electron 7. So the only thing that can evolve here is what? Sharing of electron. So this one is also what? Wrong. So let's take a look at the last one. Q is what? Sodium. S is chlorine. So my outer electron of Q is what? 1. S. Look at this B and C. B and D now. Here they identify what? Covalent. But here they identify what? Electrovalent now. So this is my Q. This is my what? S. So let me show it here. Q and S, outer electron, 1, 2, 3, 4, 5, 6, 7. So now, this is your what? Your answer, because Q and S are electrovalent bond. This is now that your P and D look alike, but the only thing that differentiates the two is that here it is written what? Covalent bond. Here it's what? Electrovalent bond. So that is the answer. Our answer here is what? D. Take note of that. The next question. The next question. The next question. Physics. When ammonia and hydrogen ion bond together to form ammonium ion. The bond formed is called Ionic Bond. B, I have Electrovalent Bond. C, Covalent Bond. D, Coordinate Bond. JAMB 1978. Also we found it in 2019. So look at this now. I think I mentioned something of the when I was explaining the dative covalent bond, or call it coordinate covalency or coordinate bond. So now they said when ammonia, the ammonia is NH3. So don't forget our 40 seconds starts now. Hydrogen reacting to form what? Ammonium ion. This is a good example of what? Dative, or we call it coordinate bond. Mind you, ionic bond and electrovalent bond, they are the same thing. Covalent bond is not there. So your answer is what? D. Because earlier I explained that when this react together, I also show you the guys the Lewis and dots section of how to identify your dative bond. So your answer is what? D. The next question, number 3. Number 3. Which of the following types of bonding does not involve the formation of new substance? Covalent, metallic, C, coordinates, D, electrovalent. UTME, So this now, it's not as simple also. Earlier I explained just 3 other types of chemical bond. I explained the covalent bond, which you can form a new compound. So, and I said which of the following types of bond does not involve. So covalent bond form a new substance because a compound. You know, when they share, the next product will be what? The new substance. So the other one is what? Metallic. Metallic does not form a what? A new substance. Coordinate bond form a new substance. Electrovalent bond form a new substance. I show you guys the explanation with example under what? Covalent bond, electrovalent bond, and covalent bond, coordinate bond, to show you guys how they form this substance. So our answer here is B for 2000. So the next one is an evolved diagram. Next one is number 4. Number 4. I have this. So the diagram represents an atom that can combine with chlorine to form dash. So A, we have a covalent bond, B, an electrovalent bond, C, hydrogen bond, D, a coordinate bond, JAMB 1998. So look up, class. With this now, the diagram represents an atom that can combine with chlorine to form dash. So what is that atom that this thing you have here now? Where you count? So let's go. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 electrons. And the element with 20 electrons is calcium. Are you seeing this now? So we have calcium here. So the next thing to do now is when calcium combines with chlorine now, which types of bond will exist there? The bond form, as I've explained for earlier when I was explaining what we call electrovalent bond, that calcium chloride form what we call ionic bond or electrovalent bond, because it involves the transferring of electron from a metal to a non-metal. So your answer is not a covalent bond. It does not involve sharing. B, an electrovalent bond. C, a hydrogen bond. D, a coordinate bond. So the answer is what? An electrovalent bond. How? Let's show it. The outer electron here is what I'll be using. So I have 2. Chlorine here we have what? Calcium. Outer electron is what? 7. This 7. So one of these will react to this. You can see now the transfer of electron from a metal to a non-metal will give what we call an electrovalent bond. So I'm moving to the next one. Number 5. So number 5 here. An element will readily form an electrovalent compound if its electronic configuration is 288, 284, 285, 281, JAMB 2005. So now this, an element will readily form an electrovalent compound if its electronic configuration is what? So now this one itself has completed octets, so wrong. So among all the elements you have here, the first one, A, that we have argon. B, we have this silicon. C, we have phosphorus. D, we have sodium. That is the secret to this question. So sodium is the only element with this electronic configuration that will form what we call a electrovalent and electrovalent what? Compound. So your answer is what? D. So the next question, number 6. Number 6. The bonding between water molecule and hydrogen is dash. Dative, metallic, C, D, covalent. JAMB 2018. So this is number 6 question. So let me put down the number 7 question here. We have number 7 here. An element with atomic number 12 is likely to be electrovalent with valency of 1, valence with valency of 2, C, with a valency of 3. Sorry, covalent. So D, valent with a valency of 4, JAMB 1986. So left with 3 questions. So look up. The bonding between water molecule and hydrogen is, so you draw it. Water plus hydrogen, we give what we call what? Hydronium ion. So this kind of compound belongs to what we call what? A dative bond. Not metallic, not covalent, not what. Don't do the mistake of picking this for covalent bond, it's wrong. Your answer is what? Dative bond. Because I explained this, that when water molecule reacts with hydrogen under dative bond. So our answer is what? Dative. So the next one, an element with atomic number 12 is likely to be, so this element with atomic number, element with atomic number 12, that's what? Magnesium. And what is the charge of magnesium, you know? So, and for you to be able to determine the charge of any element, the outer electron from group 1 to 3, the outer electron will determine the charge or the valency of that element now. So the outer electron of magnesium is 2. So let's check now. And magnesium can only form what we call an electrovalent bond. So C and D is not there. So your answer is between A and B. So that's why for your JAMB, be very, very cautious of the kind of answer you choose. Because out of the 4 options, we have 2 answers there. One is what most correct, one is what's correct. So you should go for the what? Most correct. So the answer, electrovalent bond with a valency of 2 because of the charge of what? Magnesium. So my answer is what? B. So let's play with the remaining 3 questions. So the remaining 3 questions. Number 8. Which of the following the following types of bonding does not involve the formation of new substance? Yeah, since I've explained this earlier before, so we have A, covalent, B, metallic, C, ionic, D, we have dative bond. Okay, they only change the word ionic and dative bond here. So this one is 20,000 JAMB. They say it's down. So our answer is what? The same thing we did before. The answer is metallic ion because they only change the words. Instead of electrovalent, they use what? Ionic bond. So number 9. Number 9. Elements X, Y, and Z belong to group 1, 5, and 7 respectively. Which of the following is true about the bond types of X, this is down. A, both are electrovalent. Both are covalent. C, Y is covalent. D, XZ is covalent, and YZ3 is electrovalent. That's JAMB 1994. So this one is very what? Technical. You can see that I said elements Y, X, Y, Z belong to group 1, 5, and so what I'm going to do is X is equal to group 1, Y is equal to group 5, and Z is equal to what? Group 7. So let's, your X is equal to sodium for group 1, Y phosphorus, here let's use chlorine. So your Z, we have Cl. So now the question now is, which is true about the bond types of XY and what? XZ. So let's see. My sodium is 281. Phosphorus we have 285. Here we have 287. So how can we have our XY? I said both are electrovalent. This is my X. This is my what? Z. Both are electrovalent. X and Y, they are what? Electrovalent. Yes. Both are covalent. So is your X and Y, I mean X and Z, are they covalent? No. Is your Y and Z covalent? So that's our question now. So what is our Z? Our Z is chlorine should have what? 7. So for you to have your answer, A and B is not there. So the option left is what? X and Y, I mean X and Z is electrovalent. Yes, they are electrovalent. So my X is 281 sodium. The outer electron of X is what? 1. My Z is 287. Outer electron is what? 7. So this one here, we transfer an electron here to form what we call what? Electrovalent. Yes. So the next one is Y and Z is covalent. So let's take our Y outer electron, P phosphorus, we have 5. So 1, 2, 3, 4, 5. My Z in 3 places now. Outer electron for my Z, this one is our Y. My Z outer electron, we have 287. So 1, 2, 3, 4, 5, 6, 7. Another one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Do you see it now? So let's see if truly they are covalently bonded together. We have 3. So if my Y is 1 now, how is it possible for me to what? Bring this at the middle of these 3 elements now. So it's telling you guys that truly your X and Z are electrovalent, but your Y and Z3, they are what? Covalent. So let's say X and Z, they are covalent. Wrong. Because your X is this, Y or Z, this one is one what? Transfer of electron. So for what? Electrovalent. Correct. So Y and Z. Z is what in 3 places now. So how do they share that electron? So this is it. The central atom will be phosphorus. Mind you, it has what? 1, 2, 3, 4, 5. So let's see how they share. Outer electron for chlorine. 1 chlorine. 1, 2, 3, 4, 5, 6. 1 is here. Another chlorine. 1, 2, 3, 4, 5, 6. Another one, 7. Another chlorine. 1, 2, 3, 5, 6, 7. You can see now. They both share electron. So automatically our answer is what? C. Because X and Z are electrovalents, while our Y, phosphorus, combining with 3 different chlorine, which is this, we have what? Z3Y. That gives us what we call covalent bond. So C is your answer. Are you with me now? So the last question. The last question. The last question is, so you have this. So let's draw the structure. I have this. I also have this. So the inner one, 1, 2. One, 2, 3, 4. The next one is 1, 2. Don't forget the middle. The inner one is called the nucleus. So here we have the lipids and electron of Y. So they see it now. And I said the electrons of two atoms, Y and Z. So this is my Y, while this one is my Z. And Y and Z are arranged in shells as shown above. The bond formed between the atoms of Y and Z is A, we have ionic, B, we have covalent, C, we have dative, and C, we have metallic. So with what you have here now, let's count for this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Elements with atomic number of 14 is silicon. That's the first thing. So it's equal to your Y. Let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Element with atomic number 17 is chlorine. That's our what? Our Z. So how can your silicon and chlorine combine together to form either ionic bond, covalent bond, dative bond, or metallic bond? So now it's very simple. So when 4 different atoms of Z combine with one silicon, you can have it in this. You can see silicon tetrachloride. Do you get it now? So these are silicon and central atom. So the outer electron here is 4. 1, 2, 3, 4. While your chlorine outer electron, the first chlorine, 1, 2, 3, 4, outer electron, 1 of the chlorine. Another one, 1, 2, another chlorine, another chlorine. So they are sharing electron, and when they share electron like that, you can see when you look at this question, it's very well technical. They did not identify that our Z occur in 4 different atoms. Rather, they said the electron of 2 atoms Y and Z are arranged in shells as shown above. So the first thing you have to do when it comes to a question like this, first identify the elements given to you first, which I did here. Then when you look at it, when they combine together, which possible bond can they form? Are you with me now? So when they share like this, are you with me now, class? So when they share electron, it is not ionic, we know. Ionic involves the transferring of electron. Covalent, sharing of electron. Dative, equal distribution of, is not well observed, but we must have a lone pair. The answer is not dative. Metallic bond, a positive that are positive end also to what? Negative end. So the answer is what we call covalent bond. So class, I've kept to my promise that for this year 2022 JAMB, I'll be treating 20 topics and 200 questions, and this is the first part of the topics, with 10 questions each on the topic I will touch. So guys, don't forget to watch to the end, like, subscribe, and share within your friends. Thanks.